Hey everyone, I wanted to take an opportunity to kind of reaffirm and pull together all the concepts that we have been discussing in lesson 3.3, which dealt with graphs of polynomial functions. What I'm going to go ahead and do now is take a look at number 33, located in your textbook on page 186. The problem reads that we want to create a polynomial that has a degree of 5. It has roots of multiplicity at x is equal to 3 and x is equal to 1, and a root of multiplicity 1 at x is equal to negative 3. Now I know that this word multiplicity might be new to you. Basically what that means is when you set up the binomial for each of those roots or each of those zeros, it tells you what degree each of those binomials will have. And hopefully that'll become a little bit clearer as we build the problem. And lastly, we have a line here that says that we have a vertical intercept at the point 0, 9. So what I first want to note here is that I have these roots at x is equal to 3, and then x is equal to 1. So the first thing that I'm going to go ahead and do here is if I have something where it's x is equal to 3, that means that if I went backwards, in other words, if I subtracted 3 from both sides, I would get x minus 3 is equal to 0. So one of our roots is going to be x minus 3, and since it has a multiplicity of 2, that means that I'm going to square that binomial. So if we take a look at x is equal to 1, that must mean that I have a root or a 0 at x minus 1. It also has a multiplicity of 2. Lastly, we also have a root at x is equal to negative 3. So that must mean that its binomial will look like x plus 3. And it has a multiplicity of 1, so you don't necessarily have to write the exponent up there, but if you would like to, you can. So as you can see, I've started to create a polynomial here. And if you recall from class, we had said that if we added up the exponents on each of those binomials, we would get the degree of our polynomial. And as you can see, 2 plus 2 plus 1 is equal to 5. So the last thing that we need to do here is we have this, we need to figure out if there's some sort of stretch or compression. So as you might recall from previous lessons, we usually denote this vertical stretch or compression by the letter A. So right now what we have is our polynomial is y is equal to A times the quantity of x minus 3 squared times the quantity of x minus 1 squared times the quantity of x plus 3. Here is where the y-intercept comes into play. So what I can do is, I know that my y value is 9 from that coordinate. I don't have a, but I do know that my x value is 0. So at this point, we are just going to solve for our variable a. So we have 9 is equal to a times negative 3 squared times negative 1 squared times 3. This continues to simplify down to a times positive 9 times positive 1 times 3. Now 9 is equal to, if we do that multiplication, we get 27 times a. I'm going to divide both sides by 27, and then we can actually reduce this down to a 1/3. So a is equal to 1/3. So I'm going to go ahead and rewrite my final product in function notation as well. So f of x is equal to 1/3 times the quantity of x minus 3 squared times the quantity of x minus 1 squared times the quantity of x plus 3. So lastly, let's go ahead and actually graph this. So let's build off of what we spent a majority of our time doing in class. Okay. So my spacing's a little bit off, but I have everything that I need here. So I do know, again, either from the description above or from our polynomial that we created, I know that I have a root or a 0 at x is equal to negative 3, x is equal to positive 1, and x is equal to positive 3. We can also note the end behavior here. So we had said that we have a degree of 5, and notice that my a here is a positive. So that tells me that my end behavior is going to go down and up. So we have something like this. And remember that this is a rough sketch, so it doesn't have to look perfect. We also have the added bonus of noting that we have a y-intercept at 0, 9. So now, here's where the idea of multiplicity, or again, our degrees, are going to help us here. So as we are reading through this, we have a point, or we have a 0 at x is equal to positive 3. It has a degree or a multiplicity of 2, so that means it's going to bounce off of it. So we know that it's going to come down to 1 at some point, and we also note that x is equal to 1 has a multiplicity of 2 as well, so it will bounce. And since it's bouncing, it must be coming up to hit the y-intercept, and it's going to come down, and since we know that x is equal to negative 3 has a multiplicity of 1, we know it's just going to slice through. Okay. So I hope that this little catch-up / review was helpful. If you do have any other questions, please feel free to come see me.